All right, these are the notes for 7-3. We are simplifying, multiplying, and dividing rational expressions. This was why we did those skill builders, was leading up to 7-3, 4, and 5, where we need to simplify rational numbers and factor. So, for this first example, if we're just simplifying a rational function or expression, it is in simplified form when its numerator and denominator have no common factor. So we have to look at, get everything as factored as possible and make sure nothing is the same on top and bottom. So in this case, this is already factored, but I have an x plus 1 on both the top and the bottom. Those are each their own terms because they're binomials in parentheses, okay? You can't cross off like if there was just, if I put like instead of a 2, say that was a 3, I can't cross off this 3 and that 3 because this 3 is part of a bigger term. It's part of a binomial where the constant, if it's a constant, can cross off with another constant. If it's a binomial, you got to look for the exact same binomial on top. So in this case, that is what I could cross out. So on the numerator, I'm left with 2, and then in the denominator, I'm left with an x plus 3. The thing we have to remember is that when we have these things on the bottom, we can't have x being 0. So x plus 3 remained, this one did not. And if I solve that for 0, I actually get an x equals negative 1. So in my answer, I'm going to actually say, let's put that cannot equal negative 1, because that would make the whole problem not work out. And then if we do number 2 here, let me move that up a little bit. We need to factor what's on top. So you can do the box method, whatever you need to do to factor, but I know I'm going to end up with 2 binomials. Has to multiply to negative 12, so I know it's going to have a plus. I know I'm going to have a minus, and it needs to add up to a negative 4, so the bigger number needs to be negative, and I see that it's going to be negative 6 and positive 2 because those add up to 4, and they multiply to negative 12. And then I need to factor the denominator. Now, this is a difference of 2 squares. It's x squared minus a perfect square. So I still end up with 2 binomials. They end up with a plus and a minus. And I square root of 4 and I get 2. Because they have to add up to 0 because there's no x in between, but multiply to negative 4. Okay, and then I just cross off, it's as factored as it gets, and I cross out what's the same. And that leaves me with x minus 6 over x minus 2. This is the one I crossed out, and in that case, x is negative 2. So my answer, for the x, cannot equal a negative 2. Okay. Then number 3, won't let me zoom up anymore, so let's hope I can fit it in. I look at this and it's factored as it can get, and there's nothing else I can do. So this is actually already in simplified form. Okay, so that's how you're going to simplify rational expressions. And now we're going to multiply rational expressions. All right, when I am multiplying, I can multiply the numerators and multiply the denominators, just working across. I need to put that on draw. And so I have an 8 times 7 is 56. Now remember, when you're multiplying an x cubed times an x to the 4th, you multiply them, but you add the power. So that's actually x to the 7th. And this one, even though there's no power there, that means it's a 1. So I have y to the 4th. In the denominator, I have 2 times 4, and I only have the 1x, and I end up with 3 y's. All right, and we want to simplify this as much as possible. Well, I can take 56 and I can divide it by 8. So I can go ahead and just kind of deal with the numbers first. And I know I'm going to get 7. And it's going to be on top, right? Because the bigger number's on top. So we're going to see what happens on the bottom. So I already took care of this part. Okay. Now I have an x to the 7th and divided by an x. So when you're dividing, instead of adding, like when we multiplied, we added the powers. Well, dividing, we subtract the powers. And the x remains where the bigger power was. And in this case, the bigger power is in our numerator. So x stays in the numerator. And the power down here is 1 if there's no power. So it's 7 minus 1 is 6. And then I have my y's. And I have y to the 4th divided by y to the 3rd. So I subtract my powers. And I get y to the 1st, which we don't have to write. And then this actually is my answer. There's nothing left in the denominator, but we have to look at our original equation. What if, because I got rid of my denominator, what could x and y be that would make this not work? And in this case, because there's no binomials with them, they're just, on their own, there's no pluses and minuses. X cannot equal 0 and y cannot equal 0. Okay, so that's part of the answer there. Because we don't want to divide these things by 0. Another way, if at this point you struggle a little bit with how to get from here to there, remember, 56, I want the 8 to go away at the bottom. I know 56 is 7 times 8. I know that x to the 7th means I have 7 x's. And 4y means I have 4 y's. Okay. And then you actually could have taken this even farther. That 8 could have been 2 times 2 times 2 or whatever. But I already had an 8 on the bottom, so we'll leave that. Then I had 1x and I have 3 y's. And then if you cross out where things are the same, you see that you're left with a 7. You're left with 6 x's and you're left with 1 y, which gets you that. All right. So if just trying to remember the adding, subtracting, multiplying, or whatever with the powers, write it out if you need to. Okay, so number 5. Now this is not as factored as it gets, so we are going to need to factor some numbers. So if I look at the very first fraction, and multiplying, we can really get rid of the multiplying. And we can just say, oh, let's just draw that line across. But we still need to factor this bit, and we need to factor that bit, and same thing going across here, okay? So when I'm factoring, what can I take out of both 3x and a negative 3x squared? Well, I can take out a 3, and they each have the term x in them, okay, because I'm doing just this one right here, okay? I can take out a 3 and an x, and if I do that, I have 3x, this one, divided by 3x is 1, and then I have minus 3x squared divided by 3x is just going to leave me with an x. Okay, so I just simplified this one, because this is all going to equal the same thing. And then I can simplify what's under it. I know it's going to give me 2 binomials. It has to multiply to a negative 5, which means one of them's positive, one of them's negative, but add up to a positive 4. So the bigger number has to be positive, smaller number has to be negative. Those two numbers add up to a positive 4x multiplied to a negative 5. All right. And then we still on top here, I need to factor this quadratic. Okay, again, it multiplies to a negative, so I know I'm going to have a positive and a negative. So it multiplies to negative 20, adds up to a positive 1. So that would be 5 and 4, and 5 and negative 4, sorry. And then on the bottom, I still have this 3x, which when we just write a monomial times binomials, we write it out in front. So I'm moving it to the front of everything, okay? So that top, all of this equals all of this. And I know I kind of just really made a mess everywhere. So right now we're just concentrating under the green line, okay? And we're going to cross off what is the same in both the numerator and denominator, okay? So I have a 3x and a 3x. I have an x plus 5 and an x plus 5. And I see that I have a 1 minus x, but I also have an x minus 1. And those are incredibly similar. So I want to actually make that 1 minus x, I want to make it become an x minus 1. So what I'm going to do, we have gotten rid of all the things in red. So I want my numerator to have an x minus 1. To do that is if I factored out a negative 1. Because if I divide 1 by a negative 1, I get negative 1. If I divide a negative x by negative 1, I get a positive x, okay? So this right here, the 1 minus x, is the same thing as saying a negative 1 times an x minus 1. And then I have that x minus 4. And the only thing I have on the bottom is x minus 1. So now I can cancel these, and I am left with a negative 1 times an x minus 4. So let's go ahead and distribute the negative 1. So I'm going to get a negative x plus 4. But we have some things x can't equal. So when we factored, if that equals x, I get x equals 0. This gives me a negative 5. And that gives me a positive 1. So x cannot equal any of those things. So 0, x cannot equal negative 5, and x cannot equal 1. That is my answer right there. Now remember, if you're multiplying a rational by a polynomial, the rules still apply. This is the same thing as saying, okay, I have an x plus 2 divided by an x cubed minus 27. And that's times. That's the same thing as saying x plus squared plus 3x plus 9 divided by 1. Okay, and remember, you just multiply the numerators and you multiply the denominators. And then cross out all the factored things that can separate. All right, let's try dividing some rational expressions. It is just like multiplying. We just flip what comes after the division. So the first rational expression, 7x over 2x minus 10. Okay, it stays there. And then we take the other one, and now I want to say it's multiplying instead of dividing. And I'm going to flip it. So I have x squared minus 11x plus 30 over x squared minus 6x. So it's everything stayed the same. I just flipped that last fraction, and instead of divide, I'm going to multiply now. Okay? So this is what I'm going to work with. I need to factor everything as much as possible. So let's start in our numerator, because remember, we can just connect this, and this is being multiplied by that. This is being multiplied by that. And we need to factor. Well, 7x doesn't factor any farther than that. So on the top, I know I'm going to have a 7x. That quadratic can factor. So I know it's going to become 2 binomials, multiplies to 30, positive 30, adds up to a negative 11. So in that case, I know both of them have to be negative. And I get a negative 5 and a negative 6. They multiply to a positive 30, add up to a negative 11. So that is as factored as that gets. So my numerator is all factored. Now I need to factor my denominator. Well, if I look in this first binomial here, I have a 2x minus 10. And I can take a 2 out of both of those. And that leaves me with an x minus 5. Okay, because 2x divided by 2 is x. Negative 10 divided by 2 is negative 5. And then I look at this second binomial here, and I can take an x out of both, and I'm going to just write that up front there. If I take x squared and divide by x, I get x. If I take a negative 6x divided by x, I get a negative 6. All right, and I'm going to cross off everything I can cross off. Well, I have an x here, so I guess I shouldn't cross an x off with an x. I would cross that. This is the same, and this is the same. The only thing I am left with is 7 over 2. Well, that's kind of nice. Left me with nice, pretty little numbers to end with. But we do have to write down the things x cannot equal. So the things we crossed out, whoa, where'd that come from? We crossed out an x here, so that'd be a 0, x equaling 0. This tells me x equals a positive 5, and that says a positive 6. Remember, it's always the opposite when it's grouped with x, okay? But because I crossed them out, those are things x cannot equal. X cannot equal 0, x cannot equal 5, and x cannot equal a 6. So that is your complete answer. And then number 7 down here, okay, again, it has division, and I don't know where this little thing over here came from. Oh, I just got rid of too much for you. No, that was a squared. Okay, so we're going to change this up, and we're going to make it multiplication instead. So the first fraction stays the same, 6x squared plus x minus 15 over 4x squared. Okay, and instead of divide, we're going to multiply, and I flip this fraction. Well, remember, this fraction, if it doesn't have anything in the denominator, its denominator is 1. So when I flip it, I have a 1 on top, and I have a 3x squared plus 5x on the bottom. Okay, and now we need to factor things as much as we can. So if I factor this one, okay, it's going to factor and give me, now you might want to do your factor box, so maybe I'll just do that so I can remind you guys how to factor when you've got bigger things. So if I do my factor box, you write in your first term, you write in your last term, and you multiply them together. So negative 90x squared. So it has to multiply to negative 90x squared, but add up to 1x. Okay, well, that's going to be 9 and 10. Adds up to a positive. So I know the bigger number is positive. I know the smaller number is negative. That adds up to a 1x, multiplies to a negative 90x. So I fill in my boxes. That's a positive 10x, negative 9x. And I just look at this first column here. And what can I take out of both terms? So I can take out a 3 and an x. And then this 3x times what can give me the 6x squared. Okay, so 3 times 2 is 6, and I need one more x. So 3x times 2x is 6x squared. And then I'm going to just finish with the 2x times what gives me that 10x. And that'd be a positive 5. And then I finish this one with a 3x times what gives me this negative 9x. And that'd be a negative 3. And I double check it. This negative 3, this positive 5 needs to multiply to that last box. Okay, remember each row and column have to match up there. Erase all these little extras. Okay, so that's going to give me on the top, in my numerator, I have a 2x minus 3 and a 3x plus 5. Now it's multiplied times 1, so I don't even need to write that 1 anymore because anything times 1 is itself. On the bottom, 4x squared doesn't simplify any further. It's 4x squared, so I'm going to just leave that alone. And then I have 3x squared plus 5x. So I can take an x out of both of those. So I'm going to take an x out. And then I'm left with 3x plus 5. And this right here simplifies a little bit more, but I'll do that as I do that very last step, because right now I can cross off some things. Really, the only thing I can cross off is this. Okay? And while we're doing that, we know this can't equal 0, so 3x plus 5 equaling 0. If I solve for x, I get x is a negative 5/3. So that's going to help us out in our answer. We know that x can't equal that, okay? So I went ahead and just did that step while I was going. Now this is what I have left. So in my final answer, the numerator is 2x minus 3. And let's simplify this bottom just a little bit. I have an x squared times an x, which is x cubed. And then we just said x cannot equal a negative 5/3. So that is as simplified as that expression gets. So you are ready to do the assignment for 7.3 on Big Ideas.